more forces and energy. Gravitational potential energy, or GPE. Now, when objects are lifted up, they gain gravitational potential energy. And the definition for this, which is well worth learning, is it's the energy stored in an object because of its position in the gravitational field. And the higher it's lifted, the greater its GPE. And the heavier it is, the greater its GPE. Here's the equation. E with a little p equals m times g times h, where E with a p is the change of GPE, which is measured in joules because it's got energy in the name. It's got to be measured in joules. M is mass in kilograms. G we've come across before, that's the strength of the gravitational field in newtons per kilogram, and H is the change in height. Now remember, G on Earth is 10 newtons per kilogram, and you'll see that I haven't created one of my beloved triangles here. It doesn't work because I've got 4 quantities in this equation, so we'll have to make do without the triangle here. Sad. So have a go at this question. A weightlifter raises a set of weights of mass 20 kilograms through a height of 1.5 meters. What was the change in GPE of the set of weights? And then the second part, he lowered them by 0.5 meters to chest height. How much GPE was lost? Pause the video. Here's the answers. No cheating. Kinetic energy. Now, any moving object has kinetic energy. Kinetic energy is linked to the object's speed and also again to its mass. So the faster it moves, the greater its kinetic energy, and the heavier it is, the greater its kinetic energy. Here's the equation that you'll find on your equation sheet. Again, can't make a triangle out of this because there's 4 quantities in it. So E with a little k, kinetic energy, equals half times mass times velocity squared. Now people always forget to square the velocity. You must remember v squared. So have a go at this. A car of mass 1,000 kilograms was travelling at 8 meters per second. What was its KE? Pause the video, do a quick calculation, and then turn yourself upside down and check your answer. So I've got a challenging question for you now. I've got a trolley with a mass of 0.5 kilogram, which was released down the slide, and the vertical drop for the slide was 0.8 meters. I'd like you to calculate the change in GPE when the trolley reaches the bottom of the slide. I'd also like you to calculate the trolley's maximum possible speed on the slide. Now, where the heck do you start with this? The first thing to remember is that once the trolley is released down the slide, all its GPE is transferred to KE. So this means that GPE equals KE. So you'll find the answers here. Pause the video and have a go. Now we need to have a quick word about kinetic energy recovery systems. Now this is technology that's being developed in vehicles, and this includes regenerative braking systems. Now these are systems that use energy from a braking car to store energy for later use, and these increase the efficiency of a car. They store kinetic energy when the vehicle brakes. The KE is transferred to chemical energy in the battery. And this means that this energy can be later used to boost a vehicle's speed, for example, or extend the range of electric or hybrid vehicles, which means allow them to go further in between charging, or to reduce the fuel consumption in hybrid cars because you're using energy from the battery and not just fuel.